Yes, dear students, today I'm going to discuss one more concept, that is the resistance of a system of resistors. So, what resistance of a system of resistors? Actually classified into two types. So, one is resistors are in series and one is resistors are in parallel. This is a very important, dear students. Yes, this is the first I want to discuss the resistors are in series. Actually, for this due to this NCRT they given activity also. Students, if you go through activity, if you have any doubt in the activity, you can ask me. Nothing is there in the activity. In that also they are discussed indirectly. These resistors are in series only. See, I want to discuss these resistors are in series point wise. The first point is, in this combination the resistors are joined end to end. See, so R1, one is resistance, second resistance and third resistance. These three resistance are connected to join to end to end. This end is connected to C. It's the first end. This for example, it is R1 resistance. R1 resistance is the first end. This is second end is this is. The second end of R1 is connected to first end of R2, right? And see again, second end of R2 is connected to first end of R3. So for that only these resistance are joined end to end. And see, hence the second, that one I told, the second end of each resistance is joined to the first end of the next resistance, and so on, like that. Yes. And see here, the first end of the first resistance and second end of the last resistance are connected to the cell. See, the first end of the first resistance and last end of the second resistance connected to the source or cell. I am taking, sir, for example, if you take, so cell means this is also, this is a cell actually. The first end of the first resistance and last end of the second resistance connected to the source or a cell, or else we have to connect to this. Actually, this voltmeter is connected to the parallel to the resistance. Yes. See, in this combination the same current will flow. It is a very important point. In this combination the same current will flow all the resistance, but the potential difference between their ends are different according to their resistance. Very, very important point this is. In series combination, just remember that point. In series combination, see, this is a current. Already I told the current is move from, the direction of current is a positive to negative. So this is a positive direction to negative direction, right? Yes. So the in series combination the current is same or remains constant along all resistance. The current is same for R1 and same for R2 and same for how much, whatever the current in R1, the same current will be flowing in R2 only, and the same current will flow R3 also. Whatever of course you can connect it in series infinity resistance. For infinity resistance is same for current in series combination. Just to remember that point. But if you see, in series combination the potential difference is divided in across each resistance. That only see. So for R1 the potential difference is V1, for R2 potential difference is V2, for R3 potential difference is V3. Yes. Yes, that one I told. And see, let for example R1, R2, R3 are the resistors are connected in series. So hence the equivalent resistance of these resistance I will be taken Req, that is R equivalent. Suppose a current I is flowing in all three resistance is same, but the potential difference is divided across the each resistance R1, R2, R3 is V1, V2, V3. Hence from Ohm's law V equal to IR, then V1 equal to IR1. Why? Because current is same. And V2 equal to IR2. Why? Because current is same. Then V3 equal to IR3. Yes. Then, but if the potential difference between X and Y is V, then V equivalent equal to V1 plus V2 plus V3. Why? Because V does not a constant. V is different for a different resistance. So for that only potential difference is divided across all resistance in series combination. But current is same for all resistance. That you have to remember always. Just blindly you can remember. In series combination current is same or current is constant in series combination, but potential difference is divided across all resistance. So further V equivalent equal to V1 plus V2 plus V3. But from Ohm's law we know V equal to IR. V equal to IR. Then V equivalent equal to IR equivalent. Why? Because current is constant or current is same. Then IR equivalent equal to IR1 plus IR2 plus IR3. So I am taking common here I. Then see R1 plus R2 plus R3. Then I and cancel each other. Then finally R equivalent equal to R1 plus R2 plus R3. So this equation 1 tells the equivalent resistance of the resistance connected in series is equal to the sum of the individual resistance. What is that? The equivalent resistance is equal to the sum of the individual resistances. So it is evident that in series the voltage of the equivalent resistance is greater than the individual value of each resistance. So from that R equivalent equal to R1 plus R2 plus R3. For example, so R1 is 1 ohm plus R2 is a 2 ohm plus R3 is a 3 ohm. Now finally how much R equivalent? 2 plus 3, 5 plus 1, 6. R equivalent equal to 6. So for that it is evident that in series the value of the equivalent resistance is greater than the individual value of each resistances. So just again I am repeating here two important note points already I told number of times. In case of series combination, the current is flowing in all resistance is same. And second one, in case of series combination, the potential difference is divided across each resistor, right? So this is about resistors are connected in series, dear students.